Here I have the Area 3 raster from the Ottawa geodatabase. What we can see here is that we have a number of different land covers or land uses. And if I just zoom into some regions, like here, just as an example, what we see are a number of aberrant pixels that seem like they don't belong. For example, if we look at this pixel here, just zoom in a bit, bring it up. We have, I'll just identify that. We have swamp, and then we have a little pixel here, which is wooded area. Now it's likely that because this type of land cover data comes from a classified remotely sensed image, that some of these, or many of these kind of standalone pixels or a couple of pixels or cells that are very different from their neighbors are simply misclassified cells. So I want to use perhaps a majority filter. So a majority filter, if I just grab a little piece here, like that, would look at this area, and we'll have a majority filter to start with. It'll be, that's better. So that's our focal cell right here in the middle. It's a wooded area, but it's surrounded by open area and swamp. So we have swamp and open area surrounding this one wooded pixel. And we want that to take the majority of whatever's around. The problem is that within that 3 by 3 or 9 cell or 8 cell size neighborhood for this focal cell, we have an equal number. We have 1, 2, 3, 4 swamp, and we have 1, 2, 3, 4 open area. There is no clear majority. And when there's no clear majority, what will happen when we use a majority filter to try and fill in that cell with the majority type in the neighborhood, that cell will become no data. So that particular cell is going to become a no data cell when we run a majority filter over it. If we look at another cell here, for an example, let's grab this one over here, blow it up. And here again, we'll have our 3 by 3 neighborhood. We have 1, 2, 3 of those cells are swamp. And 1, 2, 3, 4, 5 of those cells, 5 are open area. So this cell, the focus one, will become a 5 because within its neighborhood, the majority of cells are open area. And so the open area will be assigned to this focal cell because that's the majority of things found within the neighborhood. So when we have a clear majority, we get an assignment to the focal cell. When there is no clear majority, we get no data assigned to that cell, and we'll see that effect now. So first I'm going to go to my analysis environments and make sure my critical settings are all to area 3. So my output coordinate system, my extent, area 3 for the snap raster, cell size, area 3, and mask as area 3 as well. Then I'll open up my Python. And the first thing I'll do is import my environment settings to see if they've taken from the global environments, because sometimes just it's buggy and they don't take. So I'll say from arcpy import env, and then I'll just say env.snapraster as an example. And hopefully that'll say, when I hit enter, area 3, so that's great. So my global environment settings are active in the Python window. If nothing showed up there, that would mean there's something wrong and I'd have to stop and restart probably. ArcGIS Pro. Next, I'll say from arcpy.sa import all, to import all the different spatial analyst functions. Then I'll make a raster variable out of area 3. I'll just call it A equals raster, and that'll be area 3. Makes it easy to, I'll call it A3. There we go, like so, area 3. Now I'll create a neighborhood object, and I'll just call it NBR for short. Neighborhood equals, and this will be a neighborhood rectangle, NBR rectangle, and it will be a 3 by 3, and then cell as the unit. So 3 cells by 3 cells. To know how big that is in the real world, well, I can just look at my properties for area 3. And I should know this anyway ahead of time, right? Source, raster information to figure out what the cell size is, and it's 10 and 10. And then if I go down to the spatial reference, the linear units, meters. So that's 10 meters by 10 meters for each cell. So 10 times 3 is 30. So this is a 30 by 30 meter cell, or 900 square meters will be the size of the neighborhood. And nothing happens when we create a neighborhood object because the neighborhood is a class. Classes have instances like we've done here. We created an instance of a neighborhood by calling the class method or function NBR rectangle and defining it as such. And nothing happens when we look at that, and if we just type it by itself, NBR, it says NBR rectangle 3 cell. So it just holds the information about the size of the filter or neighborhood that we'll be visiting each cell in the A3 variable for area 3. And I want to do a majority. So I'll call this A3 underscore MJ for majority, and that'll be equal to focal statistics, my data, A3, then my neighborhood, NBR, and then the type of statistic I want, which is majority filtering. And then I hit enter. And that now creates a new layer called A3 underscore MJ. And I'll just close my Python window for a moment. So some that we said this would become no data. So this cell here, where my mouse is, if I turn A3 on, it will still shows the same color because in fact, there's nothing underneath it if I turn off area 3. See? All these white cells are no data cells because these cells had no clear majority within the neighborhood. So that's a no data one. And I might want to look at them with the same symbology, right? And this can be difficult sometimes for rasters because our area 3, the symbology we use is a labeled symbology. So residential open area, and if I open up the attribute table, we can see that we have object ID value, count, and then land use. And it's symbolized right now by land use. Unfortunately, those type of extra attributes in the extended raster model don't transfer over as you do analyses with raster layers. So the only thing that will be transferred will be value from area 3 in the majority filter. And that's why we see just numbers here. 1, for example, corresponds to open area. 2 corresponds to residential. 3 corresponds to water body. You can see that also in here. Make sure the thing's selected here. And so in the area 3 or A3MJ, if I open the attribute table, we won't see a land use column. It's not there. So I can't transfer the symbology from land use area 3 directly to A3 underscore MJ for majority filter. To do that, I have to bring over the field land use permanently into the A3MJ table. And I can do that using a table join based on value. So the value of the cell corresponds to a particular land use category in area 3. So if I join the land use table for area 3 by value here in area 3, and then by value here in area 3 or A3 underscore MJ, that'll carry over the land use column. So I can then copy the symbology over to A3 underscore MJ. To do that, I'll go to my geoprocessing tools and join field. So join field I'll take in as my input table will be the A3 underscore MJ. The value field will be, or the input join field will be value. The join table, area 3. And the output join field, value. And then you must be sure to, because by default it will just say that, join fields. You have to be specific as to what you want to carry over. And we want land use carried over. And that will ensure that what's joined is land use and its labels to the A3 underscore MJ layer. So I'll click run. And that's completed. Now, if I click on my, or open up my attribute table for A3 underscore MJ, see it has land use now. So I'll close those tables now that they're joined. I have a land use column in each one. Then clicking on A3 MJ, so that's what it looks like right now, to geoprocessing. And instead of join field, I'll search for symbology until I see the apply symbology from layer tool. And that's how we copy over the symbology. The input layer is where I want my symbology to go, which is A3 underscore MJ. And the symbology layer is the area 3. And we want it to go type value, and that field will in both will be land use and land use for the target. So if we hadn't joined the field, we wouldn't be able to do this. And then I click run. And voila, we have A3 underscore MJ now has the same colors as the previous. And this makes it very easy to see by clicking the majority filtered one on and off where the changes have taken place. So a lot of the small single pixels have disappeared. So that's the original. And then A3MJ. The other way we can look at this is with the A3MJ selected. I can click on the appearance tab and I can click on the swipe. And then when I bring my mouse up and down, it's swiping between the two layers, showing the difference between majority and the original. Now, the one thing it's not showing us is where the no datas are, because when we swipe over like this, so I'm swiping over, this is all the original now, and then swiping upwards shows the majority filtered one. You'll notice that some stay the same, like this one here, because we're actually seeing through the top layer there. I have to turn off area 3 to see that as white. So all these white ones look like they had something in them, right? And when I went like that, it looks like they weren't changing. But all those white ones are in fact no data, like so. So all those white ones are no data cells. And That's a problem because now we have a layer with a bunch of no data cells in them. So what can we do next? How can we figure out how to fix that issue? Well, one option is to use Nibble. So if I click on my geoprocessing tool, for example, here, geoprocessing, go back, and I just type in Nibble. Then I click on Nibble. My input raster to Nibble will be the A3 underscore MJ. That will also be the raster mask, A underscore MJ. And Nibble works by nibbling into the no data cells and replacing no data with their nearest neighboring cell value. And then my output raster, I'll call it A3 nib underscore nib. And I want to turn off use no data values if they are the nearest neighbor, because I don't want any no data values left over. And I want to instead nibble no data cells. You ignore the zone raster. That's not applicable here because we're not nibbling by zone. And then I click run. And the first thing you'll notice, there's no white dots anywhere. There's no white cells. So those have all been taken care of. And again, to import the symbology, if I open the attribute table of A3 nib, I don't have a land use. So I need to join field again. So I go back to my geoprocessing, go back here, look for join field. And that will bring up the join field option or tool, and I'll click on it. My input table will be the nib one, A3 nib. My join field will be area 3 again. Oh, no, I should say not my join field, but my join table will be area 3. My join field is going to be value in both of those. And the field I want to bring over is land use. And again, I'm doing this step so that land use then stays in the table for A3 nib. And I click run. And if it's in there, then I can copy the symbology again. So there it comes. You see it just popped up. A3 nib now has a land use column. So I can close that. Then I'll go back, get my apply symbology. SYMBOL symbology from layer. My input layer will be the A3 nib, symbology layer, A3 MJ, or it could be area 3, since they both have land use and the same colors. Type value field and land use, like so. There we go. So there's A3 nib. If I turn it off, we'll see where the no data things were. See all the white cells that pop up. And back in the original land use, if I compare my A3 nib to my original land use. So that's the original land use, A3 nib. Original, A3 nib. And again, I could go back to my appearance here, click on A3 nib, and then use my swipe if I wanted to look and reveal. Like so. So that's the original land use. And then after majority and nibbling, it looks like that. And so all those small isolated patches, not patches, but usually 1 or 2 cells, have disappeared. And I have a less noisy and cleaner raster coming out the other side of this, of the other end, so to speak.